Welcome everybody to this workshop that is a joint activity between two H2020 projects, MiniStor&Renaissance. Our workshop it's called Innovative Solutions Towards Net Zero Energy Buildings and Energy Communities in Europe. And today, this afternoon, we will have the opportunity to know more about these two projects, MiniStor&Renaissance projects. And I hope you will find this presentation of interest, and I will invite the audience to pop up any question that you have using the question and answer tool that you have in the bottom of your app in Zoom. And I will like to welcome the panelists that are with us this afternoon. First of all, I would like to welcome Carlos and Paraskevi, that they will do the overview of these two projects. So if you let me, I would like to introduce first our first panelist, that is Dr. Carlos Ochoa, that is a senior researcher at the International Energy Research Centre based at Tyndall National Institute, located in Cork, Ireland. He deals with sustainable design of climate-adaptable buildings using both passive and active technologies, mostly through simulation studies. He has had research experiences in a variety of F7 and Horizon 2020 projects, and also he is the coordinator of the MiniStor project. So thank you, Carlos, for joining us today. And whenever you want to start your presentation about the MiniStor project, the floor is yours.
Thank you very much, Claudia, and good afternoon to everybody. As Claudia mentioned, I'm coordinating the MiniStor project. It's a project that has been funded by the Horizon 2020 project, a research program, sorry. Can you see the screen now?
Yes, we can see your screen.
Yes, so this project has been funded by the Horizon 2020 Research and Innovation Program, and this project has started in November 2019. The main objective of the project is to develop a residential thermal storage system that is based on high-performance thermochemical materials. It's aimed to be compact and with high performance. What we are trying to achieve in this project is to reach 10.6 times the storage capacity of water, but the energy that powers the system is based on photovoltaic thermal panels, PVTs. The total storage material has been, the total storage material has been calculated at 0.72 cubic meters, with a flexibility to use both thermochemical and phase change materials. The expected payback period is 6.7 years, with an estimated net energy reduction of 44%. And it will be powered with a smart home energy management system that will combine thermal and electrical storage so that it can sell electricity to the grid. This is the system overview. It provides sustainable heating and cooling and electricity storage. And it combines the thermochemical materials, which are a form of chemical energy that generates heat. They are contained in a sealed thermochemical reactor made of steel, and is used for daily and multi-daily energy storage. Then at the same time, we have phase change materials that store the heat in form of latent heat, and is used to supplement the storage. As I have mentioned, then the storage density is more than 10 times that of water, calculated at 15 degrees. The heat inputs to the systems is provided by a combination of the innovative photovoltaic thermal panels and thermal collectors. And the electricity, which is also one of the products from these panels, is stored as well in an electrical battery system. This is the initial concept. As you can see here, how the system works, that there is solar energy collected from PVT panels, that the heat is stored in a thermochemical material and then released to heating and cooling components that are then placed into the heating and cooling system of the dwelling. At the same time, any excess energy that is not heat is stored as electricity, which can be taken to and from the grid in order to have an additional point of revenue, as well as going to the household. A home energy management system is activated by the user interface. This means that the user can decide when to activate the system, as well as grid signals, which means when the system can sell the electricity or store it in the battery. The main components of this system are the thermochemical reactor, which has a typical capacity of 30 kilowatt hours and consists of ammoniated calcium chloride salts that are the sorbents for the reaction. It is a two-step reversible chemical reaction, and you can see here the equations that take place. The ammonia cycle is very similar to a typical refrigeration cycle, which uses a compressor, condenser, etc., in order to cycle the ammonia and make it renewable. This means that as we'll see in the following slides, that the system can compose and decompose the calcium chloride. There is also a heat pump to upgrade and release the heat of the ammonia condensation, the phase change material vessels in order to release the heat to the household, and the solar field and the battery, which provide the heat input and electricity. These slides have been prepared by our colleagues of the Center for Research and Technology in Athens, Greece. This is the charging phase for the winter and shoulder season days. The electricity is passed from both, the heat that is collected from the PVT panels is passed from to the battery as well as to a solar collector, which leads it to a thermochemical reactor. In this phase, there is gaseous ammonia that is injected into the system, that then passes through the salts, which is then collected either in an ammonia tank as liquid ammonia or a condensated heat, which is then upgraded by a heat pump and passed to the corresponding phase change materials or to the household. The discharging phase, which takes place mostly during the winter nights, we can reach a coefficient of performance equal to 1.8. And in this case, the liquid ammonia is then evaporated through a compressor and then cycled again through the thermochemical reactor that has the calcium chloride salts, which is then released to the household or to the phase change material in case it's not needed. The discharge phase during the warm summer nights allows for cooling to be produced. This is done simply by evaporating the liquid ammonia, which is then passed again to the thermochemical reactor, and then it's passed to the cooling components of the household or stored in a cold phase change material. This project will be demonstrated in a variety of demo sites, which are located in Greece, in which we have 2 sites, in Hungary, 1 site, in Ireland, there is an additional demo site, and in Spain, in Santiago de Compostela. This is the geographical location of the demo sites. And as you can see here, they have different characteristics. The demo site in Thessaloniki in Greece is actually a test benching laboratory that has the shape of a house and is highly monitored and is run by CERT. Then we have the demo site from Kimmeria in Greece, which are some student accommodation and is managed by the University of Democritus in Thrace, DUTH. We have also a single family home in Sopron, Hungary, which is managed by the company Woodspring, which is a highly efficient passive house. We have the demo site in Cork, Ireland, which is a semi-detached family home from the 70s, which is run by the Cork City Council. And we have the demo site in Santiago de Compostela in the university, which is will be demonstrated in one of the student accommodations. Even though we have the theoretical design of the system, there are many obstacles that we still need to face to implement thermal storage in residential settings. Some of these have to do with technology, with price, with regulation, and consumer acceptance. The technology, we still need to have sufficient studies to exploit the potential of the material properties with safe and reliable implementation. This means that we are currently limited by certain limits of the amount of chemicals that can be used because the technology doesn't allow to do more. The price, we have to say that it's quite expensive compared to well-established technologies, but these well-established technologies, for example, water, is not as efficient as it could be. We also have the obstacles from the regulation, that they need to be updated to the newest technological developments, which can allow safe operation of these systems. And also, we need to deal with consumer acceptance, because otherwise it will never be accepted if the consumer doesn't feel that it's a safe system. So this is my presentation. So I don't know if you have any questions.
Well, thank you very much, Carlos, for your presentation, for your overview of the MiniStor project. It's just an overview. We don't have the time to digging in the technologies, but if you have any questions about how it works or more technical questions, you can use the question and answer the feature in Zoom, just to ask anything you want Carlos to answer here. And I will now present our next panelist, that is Paraskevi Dimitriadou. Paraskevi is a civil engineer with Masters in Hydraulics Engineering, focuses in renewable energy, both acquired from the Democritus University of Trás and the Engineering School of Chantilly. Currently, she is a research associate in the Democritus University of Trás, the Department of Production and Management Engineering, and the Laboratory of Mechanical Engineering, and participates in the implementation of European-funded projects. She has previously worked in the private sector for more than 10 years, where she was involved in the structural design of residential and industrial buildings. And she will be the one to present us the overview of the Renaissance project. Paraskevi, wherever you want.
Hello, everybody. I'm Paraskevi from the Democritus University of Trás. I will now share my screen. Just give me a second. Okay, can you see my screen now?
Yes, we can.
Okay. So I'm here today to present you of an overview of the Renaissance project. Our team consists of 15 partners with Vrije Universiteit Brussels as our coordinator. For some context, energy is mainly generated in large power plants and transported to the consumer far away from the production site through energy grid. Such a grid contributes significantly to greenhouse gas emissions and is inherently inefficient. Energy losses up to 15% of power generated. Local energy communities of prosumers could allow for energy trading within and among communities, increasing the amount of locally produced energy and the share of renewable energy in the whole picture. Technology solutions for local energy communities have been mostly developed and new business models are emerging, but there is a lack of consumer-centric solutions and interoperability across platforms. The objectives of the Renaissance project is to deliver a community-driven approach to implement new business models and technologies supporting clean production and shared distribution of energy in local communities. To this aim, a proven community-driven approach, which is scalable and replicable globally, will be realized in 5 steps: analyze, design, integrate, demonstrate, replicate. For the first 2 steps, analyze and design, already at the start of the project, energy communities were actively engaged in the multi-actor, multi-criteria analysis, MAMCA for short, to evaluate demonstrators' business ecosystems, promoting consumer participation and building consensus around site-specific new business cases. Secondly, demonstrators are analyzed with a multi-energy site analysis tool, a software already used to optimize local energy systems configuration to set the basis for the design process of the Renaissance Energy Island software replicator, namely Re-Energize. Thanks to the open source public data available from the Vrije University of Brussels, such enhanced tool will turn energy flows between nodes into monetary values, and spatial information will help assess profitability of new business models. As a result, for any type of microgrid considered, it will provide energy communities and informed guidance and increase overall efficiency. As for the integration part, based on a secure, interoperable, and scalable blockchain architecture, the Renaissance platform, is being developed to interconnect all existing demonstrators' energy vectors into a unique, decentralized, multi-vector energy services market, where consumers will interact and perform financial actions defined by smart contracts, which limits are established in real time. For the demonstration, objective for demonstration, in this phase, the set of tools improved along the project will be validated by partners through the design and operation of local energy systems in the 4 pilot sites where technical, energetic, economic, and social aspects are considered under market realistic circumstances. And as for the replicability of the project is a core objective of the project, providing a set of solutions enabling analysis and management of energy islands, software solutions, and ICT integration. Renaissance will help optimize design and operation, minimizing the local levelized cost of energy and infrastructure investments. The pilot sites of Renaissance, in order to validate the Renaissance outcomes, their application will be demonstrated in real-life pilots in Belgium, Greece, Spain, and the Netherlands. Each pilot site represents different end-user groups, integrates different combination of energy vectors, and faces diverse challenges when it comes to design of local energy systems. There is one pilot site, a rural one in Manzaneda, Spain. We will hear about it from Miguel Fontela next. An urban pilot site in Eemnes, Netherlands, an energy island in Belgium, Brussels, and a community-based pilot site in Kimmeria, Greece, which I will have the opportunity to tell you more about next. As you can see, there are different energy vectors. For instance, for our pilot site, there are solar PV panels, wind turbines, thermal biomass storage. Our end users are mainly students in dwellings, but also public services inside the university, and the scope for our part is lowest as possible operational costs through gamification. Thank you very much for listening to me. If you have any questions.
Thank you, Paraskevi, for the presentation of the Renaissance project. Well, we just hear the main concept of the projects, but what we want to present also today in this workshop in Galician Innovation Days is some of the pilot sites that are demonstrating this concept, this approach to booster energy communities and to improve the use of renewable energy through thermal storage in Europe. First of all, we will know more about one of the demo sites that was mentioned about the MiniStor project, the Sopron MiniStor demo site located in Hungary, that will be presented by Zoltán Pásztory from Woodspring. Zoltán is the director of the research division of Woodspring company. He has about 20 years research experience and is the author of more than 50 scientific papers and books. And he has been dealing with improving energy efficiency in buildings since his student period. So Zoltán, welcome to this workshop. You can share your screen, your presentation, and let us know more about this demo site. I will ask you please to stay with your camera on to people see you when you're talking. And if you can also put your presentation in full screen mode, that will be great. Thanks.
Thank you very much. And I greet everybody. May I have the feedback to seeing my screen?
Yes, we can see your screen. Can you put your camera on, please?
I did.
Well.
Oh, I'm sorry. It was my fault.
No worries.
Okay.
So now your camera is on and you are sharing your screen also. Thank you so much.
So thank you very much for the opportunity to present this building, this demo site from the MiniStor project. And thank you for Carlos for suggesting us, because we like this project and we are for the improving energy efficiency, as you said in the introduction. So I don't speak much about MiniStor project because Carlos have done before. So there are some basic information, what is the goal of this project. And you can see that it's a map where the Hungarian demo site located. It can be seen in a top left corner in the country. So other capital of two countries much closer than Budapest, but this is close to the Alps. So the location is determined by the subalpine effect. That's why it's some colder winter and warmer summer. As you can see here in the right side, the minimum temperature can be in -15 degrees Celsius. It's year by year more rare is the days and the situation, probably because of the global warming, and the summer is longer and longer. So it seems to be the cooling will be the dominant energy efficiency. Today we have to heat about 5 months, but cooling is probably maximum 1 month or less. The demo site elevation is 250 meter above the Baltic sea level. The estimated heating degree hours is about 2,500. So if somebody knows what means heating degree hours, that shows a lot. And the cooling degree hours is much less. And of course, today, the heating is the dominant energy consumption. Some words about the building. It is 170 square meter is heated. The building has two parts. The upper part is a normal family house, and the lower part is an office or a research lab. It's quite small. It's about 80 square meter. The Woodspring research group is located here. I'm sorry. The building was planned to be a passive house or a nearly zero energy building. And this night was about almost zero temperature here in Sopron. But in this season, the heating was not turned off. So it's not needed heating till now. So that shows that the building is very, very good insulated. And the inside consumption, for example, the cooking, the lighting, the computers, so the appliances produce so much heat, which was enough for the heating. And the orientation of the building is south or almost south, which helped to gain the solar gaining, which can heat up the building. So that's why the orientation is almost south. The roof was planned to be optimal for a PVT or a PV panel. And you can see here the plan. And it was a very lucky situation when the project was started. The building was during the building process. So we had the opportunity to build in some parts or some pipe, some elements, which will be very useful during the installation of the MiniStor. So it don't need stronger renovation or amendment in the building, because we have time to settle the pipes from the roof to the cellar. So it was organized. We called the building a LED home. L mean low, the E mean energy, and the D is a dream. So it's a low energy dream home, and it looks like a very, very comfortable building. And for this reason, it was very well built. So some picture about the building process. It's a construction holds, construction building. So it's not a brick. It's a structural wood building, which has a very advantageous thermal parameters. And in the next step, you can see the surface. So it's an environment-friendly surface technology. The surface here is a burnt wood. So it's an ancient Japanese technology. They don't use any chemical for protect the wood surface. They burnt it. After that, clean with a brush and impregnate with some natural oil, for example, canola or any other flax oil. So it was used, and the promise and the hope, it won't need any surface treatment during the lifetime. The building was very highly sealed. So this is an airtight building. If somebody is involved in a passive house system, then it's very important that the air could not go inside and outside from the building unregulatedly. So we built in an airing system. So that's why it's no problem if the surface and the envelope of the building is highly airtight. So it's hermetically closed. And you can see here also the tapes. The building company was very, very precise. So we are very sufficient because the building was according to the plan. And some words about the heating system. Because of the heating demand is very low, we wanted to heat the building by air. So it's not usual in the family house to using air heating, because the air cannot transport so much heat than the gas or plastic, the water heating or any other type of heating. But the calculated heat demand was 2 kilowatt hour, which is only 2 hair dryer. So it's incredibly low. And it seems to be true. So the plan is fulfilled because we measured the system. So the core element of the heating system is this unit you can see here. This is an airing system with a very small heating body built in for protecting against frost the building, the equipment. And here you can see the heating elements. So the original plan was to using electric heater. This can be seen as 3 kilowatt electric heater. And because of the MiniStor, we built in this heat exchanger. And for this will be connected the MiniStor when it's arrived. Now you can see here the test construction. We tested how much energy can be used, and we tried a water pump. So we have some preliminary steps. When we will connect to the MiniStor, then it should be ready. And we have a preliminary heater with a soil collector. If the air is too cold outside, what we bring in, then we can warm up a little with a soil collector. It's a 200-meter water pipe under 3 or 4 meter deep in the soil. So we can preheat the air, and this air go to the equipment. After that, we can heat with the MiniStor. And if the MiniStor could not provide enough energy, then the electric heater will add the rest. If the MiniStor is enough, then it's not necessary to use this system. So we will build the control panel for this. We wanted to be very high efficient in case of domestic hot water system. That's why you can see 2 boilers. And these 2 boilers is connected in a serial line. And the reason we have 2 and not 1 big, because the temperature can be different in these 2. This is the first step. And we can heat up the water 35–40 degrees Celsius. And this support the second step, where the water temperature can be 60 or 70 degrees Celsius. You can find out why is 2. Unfortunately, you cannot see, but the boilers has a heat exchanger, a liquid heat exchanger in this side, so behind the boiler. And we can connect here the MiniStor system. And the MiniStor expectedly will provide 50 or 60 degrees Celsius liquid, so this energy. And if we connect to this, then the first step can be driven by the MiniStor. And if the MiniStor can heat up for 60 degrees Celsius, then go to the second step. And from here, it can go to the consumption, to the bathroom. So that's why it was found out that we can preheat with this. If we would have only 1 boiler with a 60 or 70 degrees Celsius, then the MiniStor could not reach this temperature. That's why we wanted to improve the efficiency by decreasing the first step temperature. We have an advantage that we have not 200 liter in 160 degrees Celsius water, just 100 or a little less than 100. There is a lot of sensor built into the building. For example, it's a magnified picture from the flow meter built here. And this sensors today is continuously working, more than for almost a year, not exactly a year, probably 10 months was installed. In the left side, you can see the weather station, and we can see the local weather station. So you don't need to use maybe a 60 or 30 kilometer far airport or any other meteorological station data, because we have a local oven data. And there are some electric meter here and the gateway what was installed to the building. And it seems to be a very successful monitoring system. And we expect that the project will be very, very useful and very many information will be collected and learned a lot concerning the improving energy efficiency of building, concerning the heating and the domestic hot water. And I came to the end. I try to be fast because the chair sometimes angry if somebody speaks too much. Thank you very much. Bye.
Thank you, Zoltán, for this very comprehensive presentation about the demo site in Hungary. We see that it's a demo site that is not built for the MiniStor project, but we can take advantage, the project can take advantage of the building itself to implement the system in the best way. Now I would like to invite Miguel Fontela to talk us a little about one of the demo sites of the Renaissance project that is located here in Galicia. It's the Manzaneda Sky Resort. And first some introduction about Miguel to know more about him. Miguel Fontela has been working in energy transition projects for the last 18 years. His expertise area ranges from technical implementation of energy efficiency, renewable energy, smart grids, energy management projects, to ESS contractual and financial models, energy saving measurements and verification, energy transition planning, etc. Currently, he is the technical director of the Green Deal and Sustainable Engineering area in the company Entity Data. That is one of the companies involved in the Renaissance project. And Miguel, when you're ready to present the Manzaneda Sky Resort demo site, please go on.
Thank you very much, Claudia, for the introduction, and also to FEUA and Xunta de Galicia to give me the opportunity to present this project and the pilot site of Manzaneda. Are you seeing my screen? My presentation?
Yes, we can see it. If you can choose the full screen mode.
I thought I have done that. Let me just check. Is now in full screen?
No, it's not. Maybe you can try to share the screen again. Sometimes if you don't do the first step, doesn't allow them to change the.
Okay. Let me try it again.
Well, I would take these seconds to remember all our attendees. If you have any, I put the links about the projects if you want to dig in more about them and learn more about them, but take the opportunity to ask the people who are already involved in the projects to ask questions to them. Miguel, we are seeing we are seeing the presenter mode, not the screen. I think you are working with two screens, okay?
Yeah, let me then try to move.
Don't worry now, and we can see the presentation, and if you go.
Let me just try to do it, selecting the screen and not the. Just give me a second. I guess you are seeing now my screen.
Yes.
And is that?
It's full mode now. Yes.
Okay.
Go on.
Well, so I'm going to give you some information about what we are developing in Manzaneda Ski Resort here in Galicia, in the province of Ourense. This pilot site is part of the Renaissance project within these other pilot sites in Belgium, Greece, and Netherlands. So first of all, Manzaneda Ski Resort is a resort located in the northwest part of Spain, in a mountain area in Ourense, a quite rural and isolated mountain area. And the ski resort has, I think, some peculiarities or features that makes this resort quite interesting for this kind of projects regarding integration of renewable energy and local energy communities. The main issues, the main features are, first, that is isolated and has a mini grid connected to the main grid through a aerial line like 15 kilometers away. And this reason, the isolation and the low energy consumption in the area, also leads to another important feature of the pilot site, and is that the distribution company, the DSO, is also owned by the manager of the ski resort, by Mesa. That is, by the way, a public, almost 100% public company, owned by the Xunta de Galicia and Diputación de Ourense. So also we have there the support of the local authorities. So we have the local authorities, a rural and isolated area, and also the participation of the distribution company, electricity company, in the pilot site, which help us a lot in the implementation of the different solutions and data integration in the pilot site. Besides, we have also many different stakeholders in this community, in this rural area. We have first different typologies of end user, of energy consumers. We have a building of dwellings of more than 250 dwellings, which has private owners and also a hotel inside this building. We also have also commercial facilities like restaurants, shops, and so on. Industrial or quite similar to industrial facilities like the ski lifts, and also a newly installed machine guns for snow, a new innovation, artificial innovation system that increase a lot the energy consumption in one of the transformation centers of the grid, and also leads to some problems when this system begins to work. It generates a disturbance in the grid, and this is something also we are trying to solve with this project. Also, they have some sport facilities like indoor swimming pool, sport halls, football facilities, well, different kind of facilities. And then we have also several stakeholders that was really interesting in this project to try to establish a conversation between all of these stakeholders and try to find the optimal design of the energy community, and to also balance and weighting all the different objectives of these stakeholders. We have here, for example, the DSO, Manzaneda, that his the main objective is to improve the stability of the grid, taking into account that is a quite isolated grid. Also, we have the manager of the ski resort, and their interest mainly is to increase the renewable share, to improve or reduce the CO2 emissions, and this kind of objectives. We have an ESCO company that, as ourselves, Entity Data, we invest in this project in the renewable energy assets, in the PV, batteries, electrical vehicle. I will talk later about these implementations in a ESCO model contract. And of course, our main interest, apart of the profitability of the systems, is the replicability of this kind of setups in other parts of Spain and Europe. We also have local authorities and nearest city councils, that their main interest is, of course, to generate local incomes, employees for the local people, and these more social aspects. So we have a lot of stakeholders with different interests, and we had to come to agree to an agreement to fulfill all these different objectives with the help of the MANCA analysis developed by the DUTH University in Brussels. Well, then I'm going to talk a little bit about the grid in the resort. That is quite interesting. As I said, is like 15 kilometers, or 25 kilometers from the connection with the main grid, and it's a medium voltage topology grid with around 6 megawatts of connected power. Other interesting thing of this pilot site is that the DSO, Electro Manzaneda, has upgraded the SCADA system of the grid 2 years ago. So we have a fully monitorized medium voltage grid, and we have access to all this data. I mean, in each transformation center and different points of the grid, we have a lot of measurements and data that we can access to know how the different integration of renewable energy, electrical vehicle, and batteries are contributing or not to improve the different metrics and variables of the grid. And also regarding the different things or the different assets that we have integrated into the pilot site, we install within the project 2 PV systems connected to two different transformation center and end consumptions. One is connected to consumers that are mainly commercial and the main ski lift of the resort. So we have a quite balanced and stable energy demand along the year. And the other PV system is connected in the Galicia building, that is the 250 dwellings building I talked about before. So it's a self-consumption system. And this system also is supported by a battery, a 20 kilowatt hour, 20 kilowatt ion lithium battery. So there we will also try to address how this battery could help in the integration of PV and also help to deliver other services like flexibility services to the market. And then also we install electrical chargers for electrical vehicles and electrical vehicle to also assess how these energy profiles of electrical vehicle charging and discharging could act jointly with the PV and the battery, and how we can optimize all these energy systems. The main, sorry, let me go back again. Well, the main thing, a part of the installation of these assets, is that we have integrated it in the platform of the project to provide different services. With this data integration of the energy consumed in all the ski resort, I mean, we have integrated more than 250 smart meters with the cooperation of the DSO. And also we have integrated the data of the new energy asset, the PV panels, the batteries, the electrical vehicle charger, and so. Also, other partners of the project has developed forecasting services to be able to analyze the energy production and demand day ahead, the next day. So we can also implement demand response scenarios and strategies. And also another interesting thing, or one of the most interesting things in this pilot site, is that we are going to test and we are right now starting the operation of a peer-to-peer energy trading, meaning that currently with the regulatory framework in Spain regarding the PV systems, the energy produced in our PV system and not being consumed in the buildings, you have to feed it into the grid with specific conditions at a price determined by the pool electricity market. So it's quite low compared with the price paid by the different stakeholders, by the different consumers in the pilot site. We are talking about a difference maybe between 150 euros per megawatt hour and 50 or 45 euros per megawatt hour. What we are trying to demonstrate is how a peer-to-peer trading between the local participants of the community that will allow them to share these surpluses of PV energy between them instead of having to sell it to the grid could work. This is based on a blockchain technology and smart contracts and auctions mechanisms that are right now being implemented in the site. So each energy renewable producer could save, based on, of course, the forecasting algorithms also implemented in the platform, could say how much energy, or maybe not energy, how much energy surpluses will have the next day, and then the different actors participating in the energy community could bid for this energy and say, well, I will pay this amount, establishing like a bidding system, and all these things, of course, supported by doing under blockchain technology. We are just starting the first test in the pilot site with this technology. So we will see in the coming year how this kind of markets could work in real time with real data and real life scenarios. This, of course, this scenario will be tested virtually. I mean, the real economic extraction in the pilot site will be the ones that the regulation right now in Spain allows, but we will have in parallel this parallel bill virtual that will show, well, if this kind of market, peer-to-peer market, should be allowed, we will have these outcomes. And well, just regarding the next steps that we are facing in the project and in the pilot site, we have already installed all the energy assets and the integrations with the data platform. That has been one of the main lessons learned in the project, the quite difficult and hard integration of different data in this kind of projects, because we have data from different sources, and without the collaboration and the participation of the DSO, it's very difficult to or it needs a lot of extra investments to be able to have all this data. And also it's not possible to optimize the design of the energy community, as we are integrating different renewable energy assets in different points of a grid. It's necessary to have the data of the topology of the grid and also the monitorization of this grid to see how these energy assets interact between them. Okay, so the main outcomes expected for the next year, that is the end of the project, should be this peer-to-peer energy trading operation, and also to assess well the outcomes and the operation of the whole pilot site with these new energy assets. And that's all from my side. Thank you very much. And if you have any questions, I'm available.
Thank you very much, Miguel, for your presentation. As I said, Miguel, if you have any questions, don't wait till the end to ask them. Well, we have one for you, Miguel. Nelly Condori Fernandez asked, considering the physical infrastructure in Manzaneda, I wonder if Manzaneda could become a living lab where researchers could conduct experiments in real settings with end users. So I suppose she was asking your opinion about that.
Yeah, I think it's a quite interesting site regarding their setups and features. Of course, as is the pilot site, I mean, and the medium voltage grid infrastructure is from Mesa, that is also owned by the Xunta de Galicia and Diputación de Ourense, so they are public bodies. I think it's quite interesting for them also to make this infrastructure available for, first, of course, the Galician innovation and research ecosystem, but also other maybe researchers, I mean. Of course, they are trying to promote this project and pilot site to be part of new innovation projects. So we are very open, and from our side, as owners of the renewable energy assets, we are also quite open to allow researchers and these kind of institutions to use our assets to conduct innovations or collaborating in another project. I think, as I said, that the DSO participation is critical in this kind of project, and is something that we see many other H2020 projects related to energy communities and integration of renewable energy within grids, and it's something that for sure we should take advantage of in Manzaneda.
Thank you, Miguel, for answering the question. I think it's quite clear. That's one thing that, as you said, all Horizon 2020 projects in working energy and renewable energy and integration want to join forces, to join efforts, and think about what we can do to work together and work better to improve the use of energy, the energy efficiency, and the energy transition in Europe. Our last demo site that we are going to know more about today is the Kimmeria demo site in Greece. This demo site is a demo site both for the Renaissance project and the MiniStor project. As an example of like we said, it could be one demo site, one institution, one organization can work with two projects together. So Paraskevi will be talking us a little more about how the Kimmeria demo site that is in the campus university is working with these two projects, and how the Renaissance project and the MiniStor project is implementation innovations related to RES energy and energy communities in the campus site. So Paraskevi, you can share your screen and present this pilot site.
Okay, I think you can see my, can you see my screen?
Yes, we can.
Okay, so to present the Kimmeria pilot site, as you said, Claudia, we work both for MiniStor and for the Renaissance project. A small description of our pilot site, which is located near Xanthi in northeastern Greece, only a little bit more than a kilometer from the city center of Xanthi. It's in close proximity to energy-intensive industries. And the whole campus consists of 8 student residences buildings, a restaurant, an amphitheater, and an energy center. It covers more than 15,000 square meters. There are 630 tenants and over 400 visitors every day. The consumption needed. The consumption noted there is 1,500 megawatt hours for electricity every year, and 2,300 megawatt hours for thermal energy per year that comes from renewable energy sources. You can see this from this picture here, what we have installed in our pilot site. There is a solar thermal field, a wind turbine, an ORC turbine, a thermal energy storage unit, biomass boiler and absorption chiller, photovoltaics, geothermal heat pumps, BMS equipment, smart meters, a weather station inside the energy center. For the MiniStor, from the implementation of the MiniStor project in the residential building G2, we selected 10 student rooms from which we provide data for heating, hot water and electricity, and will be used, all this data will be used for the evaluation and validation of the project's goals, intents and propositions, as well as for the Renaissance project, where we are using 20 rooms, monitoring them, I mean, and with the data acquired from the 20 rooms, we also provide the verification and projection of what might be the response and demand scenarios in the future. In both projects, but mostly for MiniStor, we are involved in identification of stakeholder requirements, market needs, barriers for implementation, the production of a detailed monitoring plan for the demonstration sites and a strategy for remote indoor environment data collection, testing and validation of a test prototype, deployment, installation and commission of energy storage system working prototype in the Greek site, measuring the efficiency of the integrated energy storage system in operating environment, evaluation of the system design and user experience to learn how to maximize acceptance and determine possible business models, identification of business barriers in order to formulate business models for market introduction of products developed during the project, refinement of the evaluation of the impact caused by the system on the environment and long-term performance of its components. Thank you for listening to my presentation. If you have any questions, I'm happy to answer them.
Thank you, Paraskevi. I have a question myself. Miguel mentioned that this change of data and the integration of data from different sources is quite critical for this kind of project, because you have to manage a lot of data. In your case, that you are a pilot site for both projects, do you see it possible that the data you are collecting for Renaissance project will be also useful for the MiniStor project? Are the same rooms or different rooms monitorized for both projects, or are different? And but if there are the possibility of exchange data that both projects can use, is there a possibility that you are considering or doing?
I think that there are a few rooms that we use for both MiniStor and Renaissance, but they are more. I mean, there are more than 20, but not over 30, like 20 for one and 10 for the other. Definitely, the data from that we gather for one project can definitely be used for the other project. We mostly collect data about humidity, temperature, consumption of energy. So I think both projects can benefit from all this recorded data. It's been a challenge, though, not collecting, but exchanging data. I mean, connecting to the platforms and exchanging data with all the other pilot sites and a central system of where the data is being processed. But still, you can definitely say that we can collaborate. The two projects can collaborate and benefit from the measurements we take from one project for the other. We have also acquired a weather station for during the implementation of MiniStor, and we also collect data about the weather conditions during measurements and during testing of the prototypes. We will during the testing of the prototypes. So that's also additional data for
Thank you
for
so
the
much.
projects.
Thank you so much, Paraskevi, for answering my question. And I don't know if anybody from the attendance has other question before we move to the last talk of this workshop. I let you a few seconds to think about it while I introduce you to our last panelist today. We wanted to end this workshop talking about one crucial figure for the future of the energy transition in Europe that was mentioned by all the panelists in their presentations. That is that the end users. We see that there's a lot of innovation and research doing to improve the use of renewable energies, but how to involve the end users, how to convince the citizens that these are innovations that are beneficial for them, not only for the whole planet and the environment. And for talking about that, how the end users can benefit from the technological advances of projects such as MiniStor&Renaissance, here we have in this workshop at Galicia Innovation Days, Alberto Belda González, that is a research engineer within the energy division at Cardiff Technology Center in Spain. He participates in national and international research and development projects, developing tasks related to energy modeling, control of energy scenarios and projections. He is also the project coordinator of Local RES, another EU-funded project oriented to boosting the creation of renewable energy communities from a collaborative approach. So Renaissance project and Local RES, I think you have a lot of in common also working on. And Alberto is also part of the MiniStor project, where also I forget to mention before, but we here from FEUGA are also involved in the MiniStor project as communication and dissemination leaders of the project, and that's because we are organizing this workshop today with the support of the Xunta de Galicia to let you know more about the New Horizon Europe program, but also the projects that are working right now today, in this case in energy. And Alberto, I don't steal much time from you, so please, you can share your screen and start your presentation whenever you want.
Thank you very much. Can you hear me?
Yes, we can.
Okay. One moment. Can you see my screen?
Yes, also.
Okay. So good afternoon, everyone, and thank you all my colleague, the rest of panelists who have presented about these two projects. Indeed, I will talk today very briefly about residential prosumers and in general about prosumers, and I will try to introduce how their role in the energy transition is crucial and the importance that they will have in the future of the energy sector in Europe. So first of all, a bit of context, let's say. So it is clear for everyone that we need energy. We need energy in our daily lives, and it is essential for the progress. However, the way we are consuming, the way we have been consuming and interacting as citizens or end users with the energy sector is changing. So now the energy sector is changing and is suffering from very profound changes towards a more sustainable energy sector. It is also interesting to say that this is not just an isolated change, but it is part of a much larger transition and socio-technical transition that is involving many other sectors just as a response to climate change. And it is also interesting, as you were saying, this last talk, but also the previous one, we are eventually talking about end users. And it is interesting to say that this new approach for the energy sector is much more human-centric and collaborative. And the idea is to use principles of energy democracy, energy justice, or a shared economy as basic principles of this new approach for the energy sector. Also, it is important to say that the energy sector, the energy transition, and these changes are mainly based on what we usually talk about the 4 Ds. So digitalization, decentralization, democratization, and decarbonization. And this means using low carbon technologies, giving the opportunity to all users to become an active part of the energy sector, also shifting, as we will see now, from centralized power plants and main actors to decentralized actors, and also taking advantage of this digitalization and these new communication technologies also in the energy sector. So let's say we are changing from the system of yesterday to the system of tomorrow. And this is not happening only regarding citizens and users, but the whole value chain of the energy sector, starting from production. So we are changing from few large plants to many small producers and low carbon technologies. Also in terms of the market, and they were also mentioning as well, Miguel, peer-to-peer trading, this is also related to this. It's a change from mostly national markets to decentralized and small markets in the energy sector. The transmission from very big and large power lines to smaller grids and small-scale transmission, and also distribution from one only direction, from top to bottom, from the production to the end user, to a bidirectional relation. And as we were saying about the consumer, so we are shifting, and this is the focus for today's discussion, from a user who merely acts as a passive actor in the energy sector of yesterday, in many cases of today as well, who only pays for their bills for energy, to a more active actor, who has been also called prosumer. So we have now this main concept, prosumer, but what is consumer? We can consider prosumer just as the natural evolution of classical consumer. So as we were saying, from this passive role to a more active role, but there's no homogeneous definition. A decade ago, more or less, prosumer was brought as a new concept when it was the very first moments of the small installations for renewable production at residential and decentralized level. So we usually referred to a prosumer when we were talking about a consumer who self-generates energy. So mainly the focus was on the co-creation. Prosumer could be was considered as the mix of producer and consumer. However, as we will see, this has changed now. And now, due to the introduction of new technologies, such as, for instance, smart appliances, Miguel was also talking a lot about this, and also Zoltán in the case of Sopron. Also, the energy storage, electric vehicles, and communication technologies. This is changing the whole situation, and also, and this is very essential, the regulatory environment at EU level has changed and is trying to empower citizens and communities, and is giving broader capabilities and services to these citizens to be more active actors in the energy sector. So now this first producer and consumer concept is too simplistic. Now we have also different, let's say, ideas, both refer to prosumer, but which can be constituted by mixing different terms. So we have proactive consumers, providers who are also consumers, or also what they are called professional consumers. But still, prosumer is not the only term. And since they have gaining many more capabilities and services, it is also very frequent. And just for you to know, that prosumers are also called competent customers, also energy citizens, active consumers, or renewable self-consumers. Even in the European regulation, it is not just prosumer, but other terms such as active consumer or renewable self-consumers. But so, given all these changes, what can we consider as a prosumer? Well, basically an individual customer, or also a group of jointly acting customers, as we were mentioning, communities, renewable energy communities, or citizen energy communities, who actively manage their own consumption and production of energy. And this is key. They actively participate in the energy sector. They actively interact with the energy sector. And just for you to have an idea of what we are talking about, it is estimated that around 7 million European citizens will produce their own energy by 2030, so that's not long from now, and around 264 million European citizens, around half its population at this point, by 2050 will produce their own energies. And this is prosumers. All these are prosumers. So you can see in these figures how the European context is promoting the creation of this kind of new actors in the energy sector. As I say, once again, the role of prosumers is essential at this point already. And also there will be a central role for energy communities. But do you want to become a prosumer? How can you become a prosumer? So first of all, the easy one is just to self-produce your energy, for instance, using solar energy, wind energy, or other renewable source or low carbon source. But also the use of smart home energy or building energy management system makes you a prosumer, as well as the energy storage, and especially a smart management of the energy storage, the use of the vehicle to interact with the grid, so vehicle to grid, as also Miguel was saying, the peer-to-peer energy trading with blockchain, demand management and flexibility services, net metering with also feed-in tariffs, or different aggregators and virtual power plants as new actors of this energy sector. And what we see now is that the benefits of these prosumers are so many, and that's why we need to foster the creation of these new actors. So they not only increase self-sufficiency, they reduce the transmission losses, as they were also mentioning, by producing at a local level. Also, we are contributing to the decarbonization with a higher share of renewables. We are reducing greenhouse gas emissions. We are reducing having a sound position before volatility of prices that we are seeing now. We are also providing a higher security of local level, or even having savings, economic savings or profits. Apart from other very important impacts, not technical, but more social or cross-sectoral, such as a higher awareness for citizens, and also fostering innovation, competition, etc. Unfortunately, as we see, this is not something new. We have examples of MiniStor&Renaissance showing that the European Commission is trying to foster and empower citizens by means of these European projects, but they are not the only ones. There are so many, and this is the proof that the future is for renewable, for prosumers, and we all can become a prosumer today. So that was my brief presentation. So thank you very much, and I don't know if you have any question.
Thank you so much, Alberto. It was a very nice presentation about the crucial role that we all have in this energy transition in Europe and in the world also. I will invite our attendants. If you have any question to our panelists, we have like 8 minutes till the clock rings to ask your questions. Also remind you that these days, the Galicia Innovation Days, you can use the platform, the Bitmatch platform, to request a meeting, a B2B meeting, a private meeting with some of our panelists if you want, or the other attendees that are these days following the Galicia Innovation Days talks and workshops. And I invite also the rest of the panelists, Carlos, Miguel, Zoltán, and Paraskevi, to make, if you want, some comments about what we hear today, about the challenges that your projects are facing to boost and improve energy sector in Europe, and maybe ask another colleague from other projects something, if you want. Yes, Paraskevi, you can talk.
Yes, thank you. I have just a short comment. Apart from the technical part of the projects and the innovation in technology that derives from them, a very, very important issue is raising awareness. In many of the places where we have our pilot sites, where we work, renewable energy sources, local energy communities, many people not even heard of them. So, and all the possibilities, not only for making money or saving money, but for the environment, for better chances for tomorrow. I mean, this is also a very, very important issue that our projects face and help with, and it's very important that all these things are being done with the help of the European Commission, the funding, and all the other ways that we can promote our projects and our goals. And I mean, apart from the technical innovation. Thank you.
Thank you, Paraskevi. Somehow related to what you said about awareness, we have a question from one of our attendees, Nelly. She comments that it is very interesting to hear from the evolution of consumers to prosumers. One of the actions is to increase awareness on sustainability. My question is, how sustainability should be understood or defined just to contribute to enhancement of this awareness? Alberto, maybe you can answer Nelly.
Yeah, well, I can try because the question is not easy. Actually, if I had the right answer, probably I would just be rich, probably, because it is quite essential to know. I think it is very related to what Paraskevi was also mentioning. So having a high awareness of people is key. And the point is that in many cases, I think that the weakest point of these European projects is that people may know that something is going on around them, but they do not know what is it exactly. So I would invite even all the demos here to talk, or maybe to know, to just let us know how they usually struggle to communicate to the rest of users of the facilities who may not be involved. And this is, I think, one of the core points to increase this awareness. But also, I think that, first of all, in this kind of new concepts, such as prosumers or renewable energy communities, I think there are different phases, and we cannot reach just the latest one, the last one from the beginning. So there's a process first about learning, and then about planning and communicating, and then about implementing and having something like a normal, something similar, like when a product is launched. So you have the early adopters, and then it is crucial for them to communicate and show how good they are and how much they are making benefit, not only economic benefit from them. So it is crucial for the projects as, let's say, lighthouse projects, just to show the rest of users what they are doing and try to involve them even in the decisions of the project. It is very difficult because we all know that these kind of projects have or imply kind of a proposal phase where many technical partners are involved, but it would be ideal that not only technical, but also end users or citizens are involved in this process from the very beginning to ensure this awareness in European projects, and to extend this to the beyond the duration of the project.
Yeah, I fully agree with Alberto, and especially in this kind of energy community projects, because in these projects, talking about an energy community, not all the maybe building owners or householders will implement energy renewable assets or other kind of asset, but they can anyway be part of the energy community and benefit from the for example, energy, renewable energy produced, the reduction of emissions, the peer-to-peer trading systems and schemes. So in this kind of projects, is of course the word talks for itself, is building a community, an energy community. And in the Renaissance project, we pay, I think, a lot of attention to this this communication. We try to, well, we are delivering apps and social media tools for the local community. Also, we, I mean, pay a lot of attention and spend a lot of resources and money in workshop in the beginning of the projects to perform the MANCA analysis. That is a methodology developed by the BUB University to engage all the stakeholders in this kind of project, not only the stakeholders that are going to invest in the renewable assets or other kind of assets, but also the stakeholders that are part of the grid or the community, and of course will be affected by the different implementations in their community. So I agree that we have a long path to walk in this social awareness and participation is critical and very important. And most of all in these energy community projects, because there are other projects as well. You are going to test or install something in some facilities or buildings, and you don't care about your neighborhoods. But in this project is critical. So I agree, and we are start working and changing also our minds in this kind of approaches, because that is maybe the most difficult thing.
Thank you, Miguel. I don't know if somebody else, some of our other panelists, Carlos or Zoltán, or want to comment on this. How we have to understood or define sustainability when we talk about energy to convince consumers that they don't have to be only a passive element of the energy sector. Is the money the main driven for them? Or if we talk about sustainability, we have to link that with resilience, for example? I don't know. Carlos, do you want to comment something on that?
Yes, Claudia. Yeah, I would say that money is only part of the equation. We also need the motivation as well as to see the practical side and pragmatism. That consumers will see that their bills can be reduced, that they can do something meaningful for the planet and for themselves, and also that these measures will help them avoid, for example, overcharging the grid, which in the end produces blackouts, having more thermal storage, which also allows them to be more independent in case of severe weather. So all these elements in the end, they play for the benefit of the consumer. But as Bula and Miguel were saying, and as well as Alberto, we need more awareness that these technologies exist and they can benefit the consumers. Obviously, they're still in many of them have high price, but we need the push also from the market to bring them down in price.
Thank you, Carlos. Well, we are a few minutes over time, but if there are any other questions from the attendants, we will wait for you if you want to ask something. Anyway, I remember you that all these sessions, the Galicia Innovation Days, are being recorded and they will be uploaded also to the YouTube, so you can go to see them and maybe do some review what we present today. And if you want to contact the projects to ask them, I put in the chat the website of each project. They have also a contact form address you can write them. And I don't see any questions coming, so I will just say thank you all. Thank you, Carlos. Thank you, Miguel, Alberto, Paraskevi, and Zoltán for joining us today in this workshop, Innovative Solutions Towards Net Zero Energy Buildings and Energy Communities in Europe. I hope the attendants found this workshop interesting and maybe help you to learn more about what European projects and the Commission is financing these Horizon 2020 projects to accelerate and make possible the energy transition that is just a few years ahead. We say that for our next goal is the 2030 year to go climate neutral. And thank you Renaissance project, and thank you MiniStor project for joining us and be with us. Thank you the attendants who listened to your presentations. And thank you for Xunta de Galicia for supporting these Innovation Days, Galicia Innovation Days that FIUGA is organizing this week. I invite you all to register and attend the other days that are focused each day in one of the topics of this new Horizon Europe program. And also, as I mentioned, if you want to request a B2B meeting with some of our panelists, you can ask them if they are available too. Nothing else from my side, and thank you so much and have a great afternoon. Bye.